all are eagerly waiting for this lecture, and sorry I couldn't conduct the lecture in the previous week due to some technical issues. But today I will start this lecture, and this lecture, which is on fundamentals of cryptography, will introduce you some of the very key concepts, fundamental concepts of cryptography as the first lecture of the course. And then I will suggest at the end of the lecture that what's the way you should go forward for the subject, and you can carry on the learning for this course. Okay. What I will try to cover is that that means some of the basic definitions, terminologies, the history, and some of the techniques and services which have been offered to cryptography. So the cryptography is a very old concept. It is not that it is a concept which has very newly emerged, though it has been well utilized in all the present communications and data communication services we use. So that is the essence of cryptography, which essentially gives us the way to communicate the data in a very efficient way, in a very secured way, right? If you go to the textbook definitions, like as given by Phil Zimmerman, so it is actually a science of using mathematics to encrypt and decrypt data. So this is very important because mathematics is a very core component of cryptography as well as cryptanalysis. So I will suggest that after this introductory lecture, okay, you should go for a couple of more lectures, okay, which will expose to you, okay, on the underlying mathematics, which are mathematical concepts which are pretty heavily used in cryptography. The other way of thinking this is that it is a sort of art and science of keeping your messages secure. Okay? And as we know that that means in a real world communication paradigm, security is of utmost importance, because we are not communicating with a dedicated communication channel, right? Our communication channel is shared, which means that a particular communication channel is used for multi-party communication, and hence you don't know that out of those parties, okay, who are silently trying to get your very secure message, or get your message which is very important to you, okay, and also they can corrupt the message. So the cryptography means, or cryptographic techniques, are basically to protect yourself, to protect your message, okay, from all these adversaries which can occur during the communication of a message between a sender and a receiver. And that's what is secrecy. So the secrecy here means that if A and B is communicating, what they're communicating, okay, will not be exposed to any other, okay, who are also using or sharing the common channel. Okay, and that is the entire scenario of what cryptography offers to you. So we have to know that how this can be implemented. Okay, that means first of all in a mathematical model or in a logical model, and then obviously the programming version of this, and then obviously how we implement it into the various systems. Because when we tell that we are trying to make a message secure when it is getting communicated between two systems, the system definition itself have evolved along, because previously the systems were telephonic systems where people used to communicate. Next it came the computer communication based on network and internet technology. Okay, then came the technology of thin client, okay, where the communication from the front end are very simple machines, but it communicates with a gigantic backend, which are either data centers or cloud. And now the communication is not only between the computers, but communication in the age of IoT and smart system. The communication is also between the devices. So you see the entire concept of system and communication has evolved a lot, and cryptography by its own way has also got immersed in the new platforms, either in the system level and or in the communication level, communication domain. Okay, and that's why cryptography is so interesting, and cryptography is still a very vibrant subject to study and to apply. So now, what cryptography essentially means in a very generic way. So cryptography means an encryption process, and through this encryption process, we generate we convert our message to something called ciphertext, right? And obviously, okay, it is not only the message which can create the ciphertext. We require a sort of okay, another input, which is normally called as a key input, or the key for encryption. So we encrypt the message using that key, and the message becomes a cipher message or a ciphertext. And this ciphertext flows to the communication channel, which is shared by multi-party. And as it is ciphertext, okay, it is not very easy to the other parties, okay, to explore or to discover what the message is, because they don't have the key. Though there are a lot of options, a lot of possibilities that how keys can be generated, which I will go in the subsequent discussion in this lecture. But just to give a summary of what is the process, it's an encryption process which is being initiated by a key, and the message gets converted to a ciphertext, which goes through the communication channel, and the receiver receives that ciphertext, and again okay, uncovers the ciphertext using the key, okay, and gets back the plain text. So the algorithm, so cryptography, that means cryptography essentially deals with the algorithms which converts which does the encryption process, okay, which is called the ciphering, okay, or the cipher algorithm, okay, and the decryption process, which is called the deciphering algorithm. So a cipher, when we define a cipher algorithm, it means that I am knowledgeable about the process of encrypting the message within the cipher, and as well as the process of decrypting this message within the cipher. So a cipher algorithm will have encryption algorithm and the decryption algorithm, so that the message can be efficiently encrypted and decrypted based on the particular cipher algorithm. There are a lot of cipher algorithms available. There are a lot of categories of cipher algorithm available, and that is the essence of this cryptography course, that you will learn the cipher algorithms. You will know the essence of each of the cipher algorithms, and that means in which conditions they serve better, okay, and which conditions they can lose out a bit, and also how we can build the systems using this particular encryption decryption algorithms. So the cryptanalysis, which is also a particular component associated with cryptography, is the analysis part of cryptography. So the analysis part speaks about the complexity of the crypto algorithms, right? And also it works as a sort of verifier for the crypto algorithms, which tells that whether a crypto algorithm can really work good, or the crypto algorithm might not work good. So there are standard crypto analysis processes, or rather they are called crypto analysis tests. And the most common consortium for doing this crypto analysis test is the NIST. So you can check in the website. That means that you can Google NIST, and you will find that the crypto algorithms which are being used or which comes up, okay, maybe in a duration of a year or couple of years, newer versions of crypto algorithms emerge. All these algorithms are being analyzed and verified that they are quite strong enough, okay, through this NIST test procedures. Okay, and that is a part of that means, and that particular subject or that particular way of analyzing the crypto algorithms are called cryptanalysis. Okay, which serves two purposes. First purpose is you know the complexity of the algorithm. You try to find how strong is your algorithm, and secondly, whether the algorithm at all qualifies to become a good cryptography algorithm, because there are attempts to actually generate a new cryptography algorithm, and those are being verified through cryptanalysis. Though there is also a third motivation of cryptanalysis, which is unethical, which is basically done by the attackers. So attackers also perform a sort of reverse process, okay, of that means actually from your cipher data, can they get back the key? Okay, so getting back the key from the cipher message also involves a lot of analysis, a lot of statistical analysis, and maybe if your cryptography algorithm is not strong enough, or you haven't chosen a right key, okay, then through cryptanalysis the attackers can get to the key of your message, and once the attackers knows the key of the message, then the attackers can easily break your ciphertext and get your secret message. So cryptanalysis in that sense can be used for good purpose, okay, and in one sense can also used for a very wrong purpose. Okay, but why we need to know cryptanalysis? Because we need to know cryptanalysis to understand the way the attackers can find the loophole in my crypto algorithm, and that analysis will help me to understand if any loophole exists in my cryptography algorithm and to cover that loophole in a very efficient way. So you see that these are actually two processes. Okay, one is generating the cipher text, which is called cryptography. Okay, and one is the analyzing the process by which the cipher text is made to make the particular process stronger. So if there are any questions from the students, okay, I will be fine to answer those. Okay, so you can one by one, you can unmute your microphone and you can shoot a question, or you can also go to the chat window and can type your question. I will try to answer those. If not, I will just pause for a minute and I will go to my next discussion. Okay, so I hope the students are fine with the previous section of my discussion, and now I will go to the next part of my discussion. Okay, so as I told that cryptography, though it is widely used in the present day in the various forms, but it has a long history. Okay, it is not a subject which has just evolved. Okay, so cryptography dates back to our old civilizations like Roman and Egyptian civilizations. Okay, where people used to communicate secret messages. Okay, during war times, during doing administration, their kingdoms, okay, and also doing day-to-day business. So first, first sort of cryptography, which we go back to the history. Okay, some 4,000 years ago, people discovered that there's something called hieroglyph. Okay, and this hieroglyph is an Egyptian concept or an Egyptian way of describing things, and the way they used is actually some sort of symbols. Okay, some sort of symbols to describe an action, okay, or describe a story. Okay, and these symbols is very difficult for a person to understand if he or she doesn't know how this what are these hieroglyphic scripts are. Okay, and so this can be considered as some form of actually okay, hiding your information. So cryptography in general can also be considered as a process of hiding your information, and that was how the hieroglyphy was used. So the people can convert their story, convert their information to hieroglyphs, and it goes to the particular recipient. Okay, and the recipient who knows the notation can decode the message, but the others not. So it solves the purpose. It solves the purpose of keeping the privacy of your message. The next very well-known type of cipher mechanism was coined in the name of Julius Caesar, and this is called the Caesar cipher. So though there are a lot of variants of Caesar cipher, fundamentally the Caesar cipher is a shift cipher. Okay, I will just explain the preliminary concept of the Caesar cipher. Though if you go to the modern materials of cryptography, you will find that there are a lot of ways the Caesar ciphers can be implemented, and lot of variants of Caesar cipher exists. So what are those? So Caesar cipher is something which is just a shift operation. So for example, if you say this, okay, if you say this particular script, okay, a message. So the message here is A, B, C, D, E, F. Okay, and what I do a shift of A, B, C, D, E, F by, so A is shifted by 3 positions. Okay, so A is now represented by D, B is now represented by E, C is now represented by F, and likewise. So all the letters in your text, okay, are represented by a shift. Okay, and this shift value can be considered as the key information by which you are securing your message. Okay, and that is, okay, and probably you know this particular, okay, you know this particular shift value. For in this case, it is the 3 bits on the right. Okay, you can get back in the decryption by shifting these characters 3 in the left. Okay, and that's why that's the way you can okay, you can very simply define that what is your Caesar cipher text, okay, for a particular message like Internet Society Ghana chapter. Okay, you replace the by I with L, and because there is a shift, okay, I J K L, and then there is a N M N, okay, N, okay, O P. So N is shifted by O by 3 places in the right, and so it becomes Q. Is replaced by W, and likewise all the characters in this particular plain text are being shifted and represented by a new text, okay, which it doesn't have any significance unless you know that, okay, that means for every letter I find in the cipher text, I have to do a left shift of 3 letters. Okay, and then you can get back again the plain text which was intended to be passed to you. Okay. Now this is a pretty simple type of approach. There is another approach what we can also apply here. So instead of the shift being a constant value, okay, you can actually make a random sequence of characters, 2 random sequences of characters, okay, which matches in the indexes. So what I have done here, okay, if you see, you have for example, I haven't worked on the entire English character character set, only a partial English character set. So what I have done, I have randomly generated characters in the upper half, and I have randomly generated characters in the lower half. Okay, and then what I do, I actually, corresponding to each character in the upper half, I have a character in the lower half, or vice versa. Okay, so you see that means you divide the English character into some two halves, and you randomly jumble up, and there will be a correspondence between a particular index in the upper half, like W, and the corresponding index in the lower half, which is N. So the table of upper half, okay, so the table of upper half, okay, table of upper half is W, and the corresponding index in the lower half is capital N, and similarly Z, H, V, G, something. Okay, all the characters have their corresponding indexes. So this can be mutually interchangeable. Means now I can replace W with N, or I can replace N with W. Okay, so this is a sort of permutation of the alphabet, and this was pretty used in a lot of previous years of cryptography, or the previous examples of cryptography. Okay, so this is the way how you can have a, okay, you can see the Internet Society Ghana chapter, okay, has been converted to a particular ciphertext. Okay. Okay. So if you have any questions, students, okay, you can ask me. So what we have covered the basic idea of cryptography, okay, and then we have covered some of the very primitive versions of cryptography which has been used, or which are in use for okay. So shall we request the others to unmute the microphone if they are not speaking, because there is some background noise are coming. So please unmute the microphone, those who are not using. Okay. So there is yeah, please.
So I'm Biplab Rudra.
Yeah.
Sir, I want to know that for a scissor cipher, we are basically using 3 as the default shifting value.
Right.
So why only 3 was chosen as the default value? Why not others?
This is just an example. Okay, this is just an example to illustrate. You can so the ultimate takeaway from this particular scissor cipher is that it is actually a cipher which shifts, or which aligns a character with another character. Okay, so this shift can be a regular shift. Okay, this shift can be a modulus shift. Okay, this shift can be of some finite difference. This shift can also be modulus difference. So just to give an example, I have stated that this is a 3, but in general there are a lot of variants of the scissor cipher. Okay.
But whenever in any document, whenever I am finding document or any other place, they are also mentioning that by default it is first chosen as 3. Then after, when it is done in advanced level, then a k value is taken as the key. where any random value can be taken.
Yeah. That's a simplistic example. So you see that I have given you an example of random also. Okay, that means just after the Caesar cipher. So in the random, what we do, we actually generate tables which are random and then map the tables. Okay, and then we find that which index position maps with which index position. Okay, and then the only issue is that means that table needs to be supplied. Okay, both of the receivers. That means okay, it's the receiver side. So it might not be that, maybe might not be a good proposition in many of the real life applications. Okay, but Caesar cipher can also work with lot of modulus arithmetic also. Okay, it is not only this type of simple linear shift. It can have a sort of very complex shift. Okay, you can use a sort of LFSR type of stuff. Okay, linear feedback shift register, where we can do some random shifting. Okay, and you can implement the Caesar cipher. So just to get you understand that shifting either in a regular way or in a random way can generate your cipher text, and that means, and why it is easy, because the task is easy. If you see the other operations, the other algorithms in the case of encryption, or that means in the case of cipher algorithms, they are very complex. So Caesar is a pretty simple algorithm, and you can implement it in a very simple. That's all. Okay.
Okay. Thank you, sir.
So any other questions from the students or from the teachers, faculty members who are there? Okay. So if not, I am moving to my next discussion. Okay. So now let us go into the more technical concept. Okay. So okay. So now why that is, if I am okay, yeah. So if I am trying to tell that I am implementing a crypto system, okay, then the question is, what actually I'm trying to do? Okay, what a crypto system tries to achieve, right? So fundamentally, a crypto system tries to achieve the following services. Okay, yeah, I mean, obviously a crypto system that means gives a sense or gives a value whenever we have a computer network, whenever we have a network, and whenever we have multi-party communications in the network. Okay? That's the underlying story. Now, in that particular type of network, what are efficient crypto algorithm or a bunch of crypto algorithms tries to offer you? Okay, what are those services? The services can be listed as confidentiality, right? Integrity, okay, authentication, and non-repudiation. So let's go one by one of what they actually means. So confidentiality means that suppose you have a locker in your bank, right? Okay, and nobody knows that what is inside that locker, right? So it is something like that. Means you try to consider this locker as your message, or the things what you have kept in your locker. That means your very valuable items which you have kept in your locker. Okay, this is nothing but your message, which is very important. Okay, which shouldn't be read, right? Like your locker, what you have kept in your locker shouldn't be exposed to any other, okay, who might be visiting the bank, okay, who might be the customer of the same bank, okay, but they will not be allowed to actually look into your locker, what the locker has. Similarly, the sender and receiver who are also using the same communication channel which you are using for your communication will not able to see the message of what you are transferring, except the receiver for which it is intended. If some way there is an opportunity for the others to also look into your message, then you tell that there's a compromise in the confidentiality of your message. So the confidentiality or the secrecy of your message is not there. And so the cryptography operations are not doing well. So the one of the fundamental job of any cryptography operation or any cryptography application is that it maintains the confidentiality of your message. Okay. Second is the tampering or the anti-tampering integrity. So which means that suppose there is something in the locker, okay, somebody knows what it is. It is one break off, that is, it is one instance of the security breach. The second instance of the security breach is that somebody picks up an object, okay, and replaces it with other object, which means that it has not only, the confidentiality is not only being broken, but it has also been tampered. Okay, and this tampering is called the integrity breach. So cryptography algorithms will also protect the message so that they cannot be modified unless it reaches to the intended receiver. So the man in the middle, okay, we always accept whenever a communication is there, okay, there will be a man in the middle. A man in the middle means a third party. Okay, also it is told, it is coined as the name is, okay, who drops into your communication, okay, and tries to either do a confidentiality breach or tries to do an integrity breach. So cryptography, so a proper cryptography algorithm will prevent both of this. That is the confidentiality of your message, and second is the integrity of your message. That means it cannot be modified or it cannot be tampered by any third party. The next service what a cryptography system offers is called the authentication. What it means? It means authentication means that when you are offering a service, okay, suppose an email service, suppose a mail service, right? So the mail services are offered by the various of your service providers like Yahoo, like Google, like so many service providers are there who offer the mail service. Now, when you log into your mailbox, what you're actually doing, you're actually authenticating yourself, because the mailbox, which has been named or assigned to you, should only be given to you. So the service, what your mail service provider is offering you, okay, at your name, should only be offered to you. Okay, it shouldn't be enjoyed by any other. So you have to authenticate yourself, and there are ways by which they go with that. Means one step of authentication, which is only giving your login and password. There are also two-step authentication processes like the bank does. In the case of bank, there is a OTP comes also in your mail or in your phone, by which you have to again resend the OTP to do two levels of authentication. And sometimes the email services also do that because when you are changing your location, when you are moving your IP, when you are in your home, you are using one IP. When you are in your office, you are using your one IP. When you are changing your city location from Kolkata to Delhi or Delhi to Chennai, or maybe from Kolkata to Singapore, or maybe from San Francisco, or maybe London. Okay, you are changing your IPs, and then the mail service providers try to double check you. Okay, and that's why they also go for two-step authentication. Okay, maybe in a more horrified world, three-step authentication will also come up, where they will use some biometric. Okay, that's a perception, but what authentication gives you is that authentication offers that the service which is being offered to a particular legitimate user. So to prove that you are a legitimate user, your cryptography system will actually go through an authentication process. Okay, and the authentication process is the end-to-end. Means it is not that you actually authenticate yourself in some midway. It is service to service. So it is from your user mail to your data user mailbox data, which is provided by the data center or the cloud service in your Google or your Yahoo. Okay, and the last one is the non-repudiation. Non-repudiation is also a particular guarantee that a particular message has been communicated by a legitimate user. Okay, that means you need to get a guarantee that, okay, suppose there are a lot of mails come, right? That means I think all of you have faced it. Okay, that means your friend mails you that I am in a great distress in some foreign country or in some city, and you please send me this amount of money. Okay, or there are also some ways that there are some mail which comes that, okay, I am from your bank, that means your internet service is in collapse, so you please give me all your personal details so that it can be restored. So these messages are actually violating this particular clause. So which means that you are supposed to get a message from your friend or from your legitimate partner. How you know that the message what you are getting is really coming from your legitimate partner? Because in the world of network, you don't connect physically. What you connect with the agents. Okay, and these agents can be really this agent can be really aligned to your physical to the person in, okay, whom you are communicating, or this agent can be very aligned and just trying to create a mask of a person and trying to take some data from you. So your cryptography technique, that means your strong cryptography protocol, can actually save you and can actually make you understand that, okay, this particular message is not from a legitimate user. Okay, and you know that digital signatures and those are very well known form to provide this type of support. So what I mean to say is that a cryptography system should take care of all these services, and there are different means, different algorithms which actually take care of all these activities, and that is called the cryptography suite. So I think some of you might have heard the term called cryptography suite. So cryptography suite means it is not only a particular cryptography algorithm, it is a series of cryptography algorithm which actually enables you to have all these services, okay, for your different applications. Okay, so any questions from the students or from the faculties? No? Okay. So I will just ask one question to all of you. Let me put it in the chat. Okay. Can you name any cryptography protocol suite which are commonly, I think anyone which is commonly used, commonly used. Can you name any one of them?
Uh, Morning, sir. This is Shubhajit Bhattacharjee. An example of protocol is SSL, MIME, all this.
Excellent. Excellent. Yeah. Yeah. So SSL is a very good example. So when we tell SSL cryptography suite, it means that it follows all the services what a good cryptography system should do. Okay. And obviously that means, as you are from computer science background, you know that why SSL is so important, and you need to also teach the people who are not from computer science or IT background to know at least about this. These SSL services are being offered. That means by the web services, okay, which offers online transactions. So whenever you do online transactions, okay, you are disclosing some very secret information, either of your bank or personal information. You should be very okay. You should take care that this particular information is conveyed through a web application, which is HTTPS, which means that they are enabled with the SSL protocol. Okay, and they needs to be judged, or their quality needs to be, that means a quality is assured by the quality assurance which a SSL should gives you. And those are the web applications by which you should do your online transactions. Okay, if you are doing your online transactions, that means in a web application which is not HTTPS, okay, then you can be in a very wrong scenario. And this you should also propagate to all your friends and your relatives who are not from the domain of IT and computer science, but just to, because nowadays in the lockdown scenario, you communicate so many things in the online. So at least the basic precaution should be that you should communicate your vital information only through the sites which gives you HTTPS encryption, or the HTTPS protocol suite, which actually means that they will enable you to actually have all this implemented. Okay. So let's move to the next discussion. We are going into the techniques of cryptography. So the techniques of cryptography are fundamentally classified into symmetric cryptography, asymmetric cryptography, and hash functions. Okay, what are these? I will have a very brief introduction of each of this. Okay. So symmetric cryptography, as the name conveys, it has something symmetry associated with it. So symmetry is in the key. So what the symmetric cryptography tells you is that the key which is used to cipher the message at the sender end, the same key will be used at the receiver end to decrypt the message or decipher the message. Okay, and they're pretty good. They are pretty fast algorithms. Okay, and there are quite a good algorithms are there, which offers you symmetric cryptography. Okay. So this is the process, and this diagram explains it. What this diagram tells you is that this particular the particular key which I have shown here, this particular key works good. Okay, both for the encryption process and for the decryption process. Okay, and that's the way it is being done. And there are very good examples of doing this. You have the AES algorithm, which is very predominant in the present application scenario. They use the AES algorithm. They use this particular public key cryptography concept. Okay. So there are good examples like data encryption standard, DES, which uses a 56-bit key, and it works on a 64-bit input of block or plain text. This is quite a good algorithm, but it has been proved. It has been proved later that the DES is not a very strong algorithm, because it only uses 56 bits in its key, and so we can generate, that means all possible random numbers, all possible numbers with 56 bits in a small amount of time, and by trial and error we can actually test the keys, and so actually breaking this crypto system is not a very hard. So that is because the key size is very small, because as you know that the computation time, okay, to unroll a given key, okay, is exponential in terms of its bit length. So as 2 to the power 56 is not a very large number, of computation steps, okay, the people can break it, and there will be some sort of brute force or some sort of pruning applied over that, which can again convert the key space into a smaller dimension, and can help you to get to know the key in a very simple way. The modification of the DES was triple DES. In triple DES, what has been done, instead of a single key, what was used in DES, the algorithm uses 3 keys. Okay, and it is not the exactly DES 3 type, but it does. I will not explain in details. I think in the subsequent lecture courses given by your faculty, you will get to know what is this, but we have to know these techniques in details for knowing the cryptography processes. So triple DES does a sort of DES, but using 3 keys, and so you can just very generally tell that it applies DES 3 times, okay, over each message to cipher it, and again to decipher it has to unroll it for three times, okay, using the keys, and then get back the message. So as we are doing it 3 times, so the complexity is actually grows in the order of 2 to the power 3 into 56 times. So that means, and it is an enormous amount of complex stuff to it have to decrypt the key, and that makes the triple DES a very strong proposition to have your crypto algorithms. Okay. Some more examples of this symmetric cryptography are that was AES. As I told, AES is very extensively used. Okay, I think I have one question. Okay. Yeah, so Pallavi, that means real-time example means I am not going into each of this cryptography technique in this particular lecture, provided I can offer you one more lecture, or maybe the lectures if you require. But I think this will be in details, will be covered up in the course, okay, in your college. Okay, so I will just tell you that there is a mathematical, okay, that means it's algorithm which takes the key as one input, and your message block as the another input, and the key size is 56 bit and your message size is 64 bit. Okay, and this mathematical function operates the key on the message and generates the cipher text. And as it is a symmetric key, this key goes to the receiver end. Receiver works on a type of reverse function. Okay, that means and unrolls the message using the same key. In the case of triple DES, you can consider that the operation what you are doing in a simple DES will be performed 3 times, okay, in a sequence. Okay, and similarly in the case of unrolling it, you will do the decryption process 3 times. Okay. In the case of AES also, okay, so the next discussion is AES. AES is a pretty complex algorithm. Okay, a pretty complex algorithm. It takes actually four stages. Okay, 4 stages. Okay. First stage is a called the add round key operation. Then it goes to that means a substitution. Okay, then it goes to then it works with mixed rows and mixed column, and then again it adds a key, that means add round key at the end. So and it is and it works in a block. So it actually breaks the message into blocks of 64 bytes. Okay, and on each of the 64 bytes you do some rounds, and the number of rounds depends on the key sizes. So if I can correctly remember, if you are using a 128 key size, you use 10 rounds. If you are using 192 key size, you use 12 rounds. And if you are using 256 key size, you are using 14 rounds. And the mathematics of all of these rounds, as I told, that means it actually takes care of 4 steps. One is initially there's an add round key operation, which is an XOR operation of the key. Okay, that with the block, and also the key is a little bit different here. That means we start with a 128 or 192 to 56 bits of keys. Okay, the 128 key means we are having again. Okay, that means okay, some bytes of keys. From these bytes of keys, we actually generate a larger bytes of keys. We're doing some internal operations. So there is also a key generation step. So there is a key generation step which actually generates number of keys for each of the rounds from the fundamental key, and then each of the round keys are operated. That means in each of the rounds for each of the blocks. Okay, and apart from these add round key operation, you have also byte substitution and mixed rows and mixed column operations. And so with this lot of operations, you actually come out with your ciphertext. Okay, and I think this is very important. I think all of you should go through the AES algorithm very well in your course, and to try to understand it from your faculty who will be teaching this course. Okay. Another example that means is IDEA, which is also very commonly used. But obviously, if you rank the algorithms, you will see that AES is the most common, and then comes the TDS, and then maybe IDEA, and then maybe the DEA. Okay, so when we are discussing the symmetric key algorithm, there are again two other ways they can be classified. Okay, one is called the block cipher. Okay, actually all the examples I gave in this particular discussion are example of block ciphers, where the data is being first broken into chunks of blocks. These blocks may be 128 bits. This block may be of 64 bytes or some bytes, and each of the blocks are being encrypted individually. So in the case of block cipher, the block cipher works very good when your data is already there with you. When you have the data already with you, which is not generated online, which is already offline data is with you, and now you want to communicate this data which has been already there offline, okay, to a communication channel, you can very well use the block cipher. Stream cipher actually works on a digit stream, which is normally 1 byte. So you actually encrypt or cipher your data byte-wise. Okay, and that's a very common process when you are doing something online, when your data is coming in a very continuous way. Okay, and you don't know that when the data will stop. Whatever data comes into your stream, you have to encrypt it and you have to communicate it. So this is called the online ciphering scheme, and a very good example of this is the RC ranges of algorithm. RC, for which I didn't give in this example due to limitation of time, but I think you should also also in your course, or you should look into the RC algorithms or RC4 and RC5 algorithms. Okay, so let's move on to the next discussion. These are some of the examples of cryptography algorithms. Okay, the sort of them. Yeah, that means so out of this RC5 and Lucifer are very Blowfish is also very well used. So any questions on the symmetric key algorithms from students?
Hello, sir.
Yes.
So I'm again once again Biplab Rudra.
Okay.
Sir, I want to know that when we will be using the stream cipher commonly, that is, which is best, either block cipher or stream cipher commonly?
So there is no such distinctions, and I will tell that cryptography people are very pretty divided. Okay, I am not a very hardcore cryptography person. Okay, in a sense, though I have implemented a lot of cryptography algorithms in many of my projects, and I have graduated 2 PhD students. That means actually 3 PhD students. One has worked on hardware cryptography. One has worked on implementing real-time security in communication channels, and another one is working on this IP based security. And also my Intel project is actually based on the cryptography. But I am not a cryptography person, in a sense that I am not a person who has a passionate for any one form of cryptography. Okay, I actually take cryptography as an application, and I try to implement those algorithms in the systems. Yeah, we're also working on, that means I started a new PhD project where I am using AI to find the various cryptography breach, and probably some of the companies are also will work with me. But what I mean to say, in the case of hardcore cryptography persons, are the persons who are actually well involved in generating new algorithms. So if you see those persons who are basically comes from a very that means a mathematical background mostly, okay, they have their own choices of cryptography. Okay, that means some prefer stream cipher, some prefer block ciphers, some have their own choices. So I will not go into that debate. But what I can tell you, in the way we have implemented the ciphers, okay, block cipher plays a good role when you have a sufficient amount of data to encrypt, because block cipher takes a time. Okay, block cipher is time consuming because you have to encrypt a large size block. Okay, that means it helps you to save your resource when your block is already available with you. Okay, because you are doing a large amount of transfer, and for that transfer you are doing a complex operation, but you are doing a large transfer. But in the case of stream cipher, you cannot do a large transfer because your data is not available. Okay, that means in the most of the case of online transfer, online data, that means okay, real-time transfer of data. So stream cipher is a good way when we have a small amount of data gets accumulated in every cycle in your system. Okay, and you want to actually communicate that data. Okay, that means in a small that means in a very small instance, in a very short amount of time. So it depends on the need. Obviously, if you see in the algorithmic wise, okay, AES is pretty strong. RC algorithms have proven to be broken. So we invested a long time in implementing RC4 algorithm. Actually, one of my PhD student who is very good in this took a long time, okay, approximately 1 year, to implement the RC algorithms in various forms. There was a phenomenal paper from one of the groups in ISI who implemented the RC algorithm, RC4 algorithm in a very small amount of resource. we surpassed that work. We actually did it in a much smaller resource. And you can find this paper of us in the IT journal, the IT Digital Techniques. You can get the paper of my student Roura Pal and myself. But RC4 later, when we gone into this project, we saw that the RC4 has been compromised. So stream ciphers has a little bit, that means that means more prone to get compromised than block cipher. But stream ciphers are first. Stream ciphers takes you a small amount of time. So if you have a real-time data communication channel where you have to flush out your data very fast, okay, maybe stream cipher is the way. But maybe again, cryptanalysis people can tell that stream cipher has certain weakness and block cipher is pretty strong. Okay, so that's my viewpoint. I will not tell this is bad, but I have given my clear opinion in terms of implementation and designing algorithms. Okay. Okay.
Oh, thank you, sir.
Okay. So let's move into the next thing. So now the problem in symmetric cipher is that means they requires a key management, because you have to communicate the key to your receiver, because receiver also uses the same key. Okay, and that can be very difficult, or you have to be very careful in doing that, because your key sharing channel should also be very what I can say, very confidential. So you have to send the key in a very confidential way, and that becomes a very difficult in many of the practical use cases. Okay. So what do you do? There is a second way of doing the thing. So there is a second type of algorithm, which is a little bit complex compared to this symmetric cryptography algorithms. And these algorithms are called asymmetric key cryptography algorithms, or they are also nomenclated as public key cryptography. Okay. In these algorithms, either you name it as a public key cryptography, or you name it as an asymmetric key cryptography. Instead of a single key, we use two keys. Okay, and that's the name of public key cryptography, because in this cryptography we have two keys. One key is named as a public key, and another key is named as a private key. So how the encryption decryption occurs? So any party involved in this communication will have two keys. One is its public key, which will be known to all the users, all the other parties, okay, who wants to communicate with that individual, and the private key, which will only belong to himself, okay, and will not be revealed to any other. So which means that if A, B, C is communicating, then each of A, B, and C will have its private key as well as public key. So the public key of A will be known to B and C, whereas the private key of A will only be known to A. And same for B and C. So B will also have a public key and private key. So the public key of B will be known to both A and C, whereas the private key of B will only be known to B. And this is the way the entire setup works. Okay, how it works? So the example, so the sender here generates a plain text message, and it encrypts the plain text message with the public key of the receiver, because the public key of the receiver is known to everybody, and it encrypts it. But it generates a cipher key. But the important fact, or the interesting fact in this entire process, is that the private key. So private key is just a pair of the key which you need to decrypt the message. So that's why the name asymmetric means you are encrypting with a key X, which is a public key, and you are decrypting with a key Y, which is a private key. and X and Y are not the same keys. In the case of symmetric key, X and Y were the same keys. In the case of asymmetric key, X and Y are not the same, and hence the name asymmetric, and hence the name public key, because in the case of symmetric key, the key was only private between A and B. In the case of asymmetric key, there is a public key of A and there is a public key of B also. So if B wants to send a message to A, it has to encrypt with the public key of A, and vice versa. So this is the way how it works, and this works in a very good manner. This works in a very safe manner, and people have found that this particular way of operation, that means also takes away the need of a very secure channel of communicating the key. Okay, and that's why asymmetric key or public key cryptography is also very, very common or very familiar nowadays. So this is the way, as I've been told, you told that means sender and receiver has to distribute the public key, and there is no problem, because if somebody knows your public key, it's fine, because the message meant for you cannot be opened by the public key. Message meant for you can only be opened by your private key, and your private key is only with you. You are only distributing the public key of yours. So that's the process, again pictorially described, that you give the public key to your all the participants who wants to communicate the message. The sender encrypts the message with the public key. Sender delivers the message to you, which is a ciphertext, and you can very easily decode the ciphertext by your own private key, which is not known to anybody else. If somebody gets hold of your private key, then it's dangerous, and that's the way security breach can happen. That's the asymmetric cryptography, and so this is a mathematical concept, okay, which actually comes into the domain of algebraic group. Okay, you have to know some of the theories like Galois field or something, okay, which actually which does these operations, okay, which actually formulates that how you can generate these two key, which is a perfect match of the other. So digital standard signature, okay, those algorithms are based on this type of asymmetric cryptography. The most popular algorithm of asymmetric cryptography is the RSA algorithm, which is used in many of the applications. Though people have a perception that means in the quantum computers, I don't know how many of you know about quantum computers. If quantum computers comes up in a scalable manner, the quantum computer is already there, but it's not in that scale. If it comes in a scalable manner, okay, it can actually break this encryption, and it can actually that means make this RSA broken. But still now RSA is pretty fine, unless we have that means scale of computing which quantum computers offer. Okay, because I mentioned this because you will find that many of the comments are there that if quantum computer comes up, okay, the RSA algorithm will be broken, and a new domain of cryptography have emerged, which is called post-quantum cryptography, right? So LGAML is also another popular asymmetric cryptography example. So do you have any questions on this part of the lecture, which is the asymmetric cryptography? Okay. So if not, I will go to the last part of my lecture, okay, which is the hash function. This hash function is also pretty well used, okay, and it is a very common application in the cryptography domain. So what does a hash do? So what a hash do, hash actually generates a message digest, and hash is a one-way function. A one-way function means provided you apply hash on your message, okay, you get something which is called a message digest or a hashed value. And from this hashed value, getting back to the original message is impossible or virtually impossible, or pretty difficult. Then obviously the question is, if I don't get back the message, okay, why I at all need it? So this hash is very well used in the operations like authentication. So what it does, suppose take an example. You are entering your password in login. Okay, that means your username and password. Now what the system at the other end does? Does it compares with a password which is stored? Then the password is revealed to the user, to the administrator. So if your Yahoo or your Gmail, okay, if your Yahoo or your Gmail stores your password, okay, in a normal text form, then your password may be revealed. So actually the way they are stored is with a hash. So you set your password and it is hashed and stored in a database. When you do the next entry, you also give the same username password, and again there is a hash is generated. Now what is done, the result of the current hash and the hash which was stored against your identity is compared at the back end. And if they are exactly same, then the authentication is done, because then the message which has been entered by you perfectly matches with the message with which you registered yourself. And that's the way how the hash function works. And that's why hash is so important in actually generating your authentication. Okay, and that's the way of so what it does, it doesn't do the same job as your encryption does, but it actually forms a signature of your message. And this, okay, there is also another property, is that hash is a unique mapping. Means suppose you change the message a bit and you operate with the same hash function, the message digest what will generate will ought to have a difference. So that's also a condition of the hash function. So the condition of a hash function is that it is pretty random. It generates a random message digest in a sense. Okay, that means you cannot just try to change the message and try to come to the same hash value. And secondly, it is a one-way function, which means that you cannot come back to your message. So you cannot, so provided you know the hash function and you have the hash value, somebody cannot get back to your message and try to create your duplicate entity, duplicate identity, because hash is a one-way function. Okay. Okay, and that's what I have discussed here, is that it's not possible. That's called the munging the document. So hashing, the normal term of hashing is called munging the document. So this munging of the document is done by the hash function, and it does a message digest, and so so you cannot get back the original document. Only what you can check is that the document which generated this hash and the current document which is also generating the hash based on the same hash function, whether the two documents are same. Okay, and that inherently generates the idea of authentication and as well as digital signature. So I will quickly go to the digital signature. So this is also the way the hash is also can be used to actually protect your private key in the case of symmetric key cryptography. So you can do that, and okay, and you can do it for doing that. Okay. The common hash functions are MD5, MD hash functions. The commonest is the MD5, and there are also another set of hash functions which are SHA. I think the presently people are using SHA-3 and SHA-4. Okay, and these are pretty well used in authentication functions across different types of systems and applications. These are examples of the hash, how it looks around. You give an input, you do a hash, and you come up with a very jumbled hash function. So SHA is a very common hash function. SHA-3 is something we generated October 2012. I think SHA-4 and SHA-5 is also pretty existent at the present days. You can look into the references. So any questions up to this? Okay, so if not, I am going probably the last part. Okay, sorry, this is the last part. The last part is very interesting. I think nowadays everybody wants that to have a digital signature. A lot of documents, online documents, have a digital signature. So what this digital signature is and how it verifies the authentic signatory. So digital signature is a process by which I can guarantee that the document which is coming from the sender, okay, is actually the original sender, because the sender will use a signature which is a digital signature and which will be verified at my end by a process, and that verification will clearly give me the information that whether the document has come from the particular identity, okay, who has the signature, or it has come from another identity. So what are the process? The process is something that you first, let us look into the process by this way. Okay, so this is the document. This document is being transferred. What I have to assure is that the receiver gets the document, but how the receiver will know that the document is coming from the user whose signature I have already procured. So to enable your digital signature process, you have to first generate the signature, and this signature will be actually kept by your internal receiver also. So what it does, so you send the message, and then the hash of the message is done, and this hash of the message is being encrypted by a private key. Okay, by a private key. And this private key public key combination also works in a way that it is a little bit reverse what we do in the asymmetric cryptography. In the asymmetric cryptography, you actually use the public key to encrypt and private key to decrypt. Here it is the inverse, because I have to verify. So the receiver has to verify the identity. So what it does, this sender's public key is with the receiver, right? And this particular hash information of the message encrypted by the private key comes to the receiver. Receiver decrypts with the public key of the encryptor, and it generates a hash. And it also generates a hash with the message which has been already transferred. Now the important fact is that if this private key of the receiver, of the sender, is matched with the public key of the receiver, which means that they have already exchanged this information through, that means, okay, the already mutually settled information of the keys. In the next time, when it encrypts and when it decrypts it with public key, and it gets a hash value, and this hash value is compared, and if this two hash value comparison gives the same, gives the true, means both the hash are true, then it is guaranteed that this particular sender is possessing a true private key which is matched with the public key of the receiver, right, which was prior delivered by the sender itself. So each time the sender puts a message, it has to again sign on with its private key, and this will be again verified with the public key of the sender and compared using the comparison of the hash. And then the sender will, receiver will always know that this is the true sender who is sending this particular message. So no duplicate sender can generate this private key public key combination. So his or her, any false sender will do it in a different key, and then the hash generated will be different, and then the receiver can understand that this particular hash, this particular sender is not the true sender, and will discard its document. This is the way how the digital signature works up. So for that, you have to first generate a signature, and the corresponding public key of the signature is being transferred to your receiver side. And once it gets transferred, so there is a generation process. So generation process has two parts. One is the private key at your end and the public key at the receiver end. So once the generation is done, you can use this key. This key may be maybe some sort of value, some sort of your digital impression, some sort of image. And from that, the public key and private key are created. And then public key is written by the receiver and private key will be with you. And always you sign your document is the hash of your document with your private key, which is being, okay, which is revealed by the public key of yours at the receiver end, and the hash comparison will ensure that you are the same sender who has generated that. Okay, so this is what is digital signature, and you know that when you try to do a security function, all of this has to be placed in a proper way, and then what you generate is called a true security application, and you have made a true lock for your data or for your applications. If you have to make a true lock, then all these things need to be in place and well implemented in your system. Okay, and that's all where I end. And it's the last question what you can, with the last question slide, what I have to offer to all of you.
Hello, sir.
Yeah.
Sir, I want to know that what can we use as a...
So there are different types of digital signature generating algorithms. So normally when you try to establish a digital signature with a particular receiver, okay, you can use your some image, you can use your some ID, okay, some government ID. People lot of the they use the Aadhaar ID, the proof, okay, Aadhaar ID number, okay, a lot of other numbers, your name and your age. So from all these, they generate a procedure by which they generate the two pairs of the key. One is the public and one is the private. Private key remains with you and public key is with the receiver. Okay, and then in every transaction, you have to use that signature, means you have to use your private key and you have to generate the hash, that is encode the hash, encrypt the hash, and then the hash gets decrypted, and the hash gets compared with the hash of your message, and then your validity is being justified.
Okay.
Okay,
Thank you,
so
sir.
you have to give you some sort of data which is very close to you. Okay,
Okay.
so thank
Yes,
you
sir.
all for listening to me. My suggestion to the students is that the next discussion for this course should be the mathematical preliminaries. Yeah, I am not. That means I don't know exactly what is your syllabus of the course, but I can appreciate, because I know what are the cryptography syllabus in most of the universities and our universities. So the way you should go ahead is that you should go through a mathematical preliminaries. That means of the various discrete algebra techniques and exponential modulus techniques. And then after a couple of lectures on the mathematical preliminaries, you can now go to each of the functions in the both asymmetric and symmetric cryptography, hash and zero signature, and maybe some recent techniques like you have the blockchain if you want to intend in that way, blockchain, it's a homomorphic encryption for the cloud, and those are the recent advances which are being also done in the cryptography domain. You can get into those and you can learn the cryptography in a very good fashion. Okay, I will again tell that means I complete this lecture, and that means I only thought to give you the introductory lecture, but